Welcome to a nostalgic math chat. We are looking at IEB November 2023, question 5b. It says, in the diagram, HIJ is a right angle triangle at I. Okay, and that's indicated for us over here. Right, L lies on IJ. Okay, so there's L, such that JL is 9 units and LI is 12 units, okay? K lies on HI with KL parallel to HJ. Nice. And then we're told HJ is 29 units long. Determine the length of IK. Okay, so this is, I think, quite a straightforward similarity problem. You could look at it in terms of similarity or in terms of the theorem that talks about, I can't find a short way to say it, but there's a theorem that says if you have a triangle and you draw a line inside the triangle such that it is parallel to one of the sides, then what we know is the ratio of this side to this side will be the same as the ratio of this side to this side, right? I forget what the reason is called. I think it simply says line parallel to third side. Let me double check quickly on one of my most favorite math resources online, Siavur. So there's that result. I keep forgetting how to write down the reason. This is one of those things that I didn't learn in school. I'm definitely rusty with that reason. Oh dear. Oh yeah, okay, sorry. We are load shedding, so I am using a hotspot to connect to the internet and it is going so slowly. But yes, so this obviously comes in handy for this question because we have these two parallel lines, which tells us that the ratio of this and this is the same as the ratio of this and this. Oh, tricky. We don't have HK, so that is not actually very useful. What we have been given is HJ. So what we can definitely do then is we can prove that this triangle is similar to this triangle, because that's just the common pattern you see. If you have this situation, then you know that little triangle and big triangle are similar. So we can prove similarity between those two and use the relationship to figure out, oops, I'm being so silly. Oh my goodness, sorry. So this right angle is important. It's not there by mistake. It's actually useful. So Pythagoras can give us the length of this side, and then we know that this side is split in the same ratio as this side. So once we know how long HI is, we can use that ratio to figure out the length of IK. Okay, so Siafula has loaded. I just want to find, how do I give that reason for the theorem that I just mentioned? The reason literally says line parallel to one side triangle. Okay, cool. So let's get into the adventure. I'm not sure why I picked this question, honestly. It's not hard. And by hard, that's not to say that if you struggle with it, then there's something wrong. I just mean in terms of it's not designed to be hard. That's what I'm getting at. The trickiest thing for this question is taking note of that right angle so that it can help you figure out this side, because there is no other way to find out what that side is without using that right angle. Because even if I were to go down my similarity route, that was going to give me the length of this side. But without knowing how long this is, I wouldn't be able to find out how long that is. and the only way to find out how long that other side is by using the right angle. So the moral of the story is allow your neurons to start firing when they give you information like this. Just think, they don't give information for free in these exams, honestly. When you get to university, they do start introducing superfluous information that doesn't actually aid the solution. But in high school, whatever they give you bare minimum to solve the problem, in my experience at least. So, right. So we're going to start by working out the length of IH using Pythagoras. So IH squared plus IJ squared is equal to JH squared. That's because Pythag said so. Okay, so IH squared plus IJ, which is 12 plus 9, which is 21 squared, is equal to 29 squared. So IH squared is equal to, again, something you could just do on your calculator, but here I am suffering. So that is 8 times 50, which is 400. So then IH will be the square root of that, and of course only the positive square root, because we're talking about lengths, so we don't have to consider the negative square root. So IH is 40 units long. Okay, so then we know that the ratio of IK to KH is the same as the ratio of IL to LJ, and that's because we have a line parallel to the third side of the triangle. Okay, so the ratio between IL and LJ is 12 to 9, which can simplify to 4 to 3 if we divide both sides by 3. So we need to then split 40 by the same ratio, right? So, or actually we're just interested in IK, so we don't even have to figure out how long KH is. So we just know that IK then will be equal to 4 parts out of 7, right? Because it's the 4 part out of 4 plus 3 of, what am I doing? Busy writing 40 instead of 20. Golly wally. Okay, so this is 20. Right? And decimalically. So this will be, oh, poor calculator has fallen asleep. That times 20 is, I think let's do it to 1 decimal place. I think that's the general standard for IEB papers. Yeah, so that's what I get. Let's see what the memo has to say. So question 5B. Yes, 11,4, and we have the same workings pretty much. Yeah. So they look at the ratio in terms of IL over IJ is going to have the same ratio as IK over IH, which is, yeah. So then you'd have 12 out of 21 is the same as whatever IK is over 20. Then you solve for IK, we get to the same answer.